Hello guys, good evening. I'm here again, and I know these are rough times now that we have, and alam ko rin na yung current situation is impending the reviews and the lessons of our reviewees and students, especially in the field of mechanical engineering. So I have decided to release a series of videos, okay, explaining topics, especially in mechanical engineering. Yes. And so, to start with, for the series of videos that I will release, I will start with thermodynamics. Syempre, yun yung pinakagusto natin, di ba? Thermodynamics is the backbone of mechanical engineering. And I want to start with pure substances, especially focusing on water. Why do we really focus on water? It is because water is still, okay, by far, yung pinakagustong gusto nating working fluid sa mga power plant natin, sa mga ice plant, and sa lahat ng processes involving heat transfer, energy transfer, and lahat ng nag-i-involve ng thermodynamic systems. Yun yung pinakagustong gusto pa rin natin, di ba? Cooling system, and so on and so forth. So that's why we really focus on water, specifically on steam and ice and the other phases, of water. Now, let's start with the pure substance. Water is a pure substance. Bakit? Kasi pag sinabi mo kasing, actually, it's not only water that's pure substance. Pag sinabi mo kasing pure substance, the composition is homogeneous. Okay? Hindi ibig sabihin na hindi it's not always an element or a compound. It can be a mixture for as long as yung composition is homogeneous all throughout. Okay? So, that's the meaning of pure substance. So, for example, water, di ba? Water is pure substance because all throughout its composition is just H2O. Now, air. Is air pure substance? Baka sabihin nyo, hindi. Because, okay, air is composed of, mainly oxygen and nitrogen, di ba? We know that. But, yes, it's not composed of the same element or the same compound. But, all throughout ng air is homogeneous. Kahit 5 kilograms ng air or 10 kilograms ng air, or you take a sample volume of air, still the composition will be the same. So that is why air is still a pure substance. The moment na hindi na homogeneous yung pagiging nila, yung composition ng pure ng substance is not pure already. Okay. So I hope I've been clear with that. And ano bang mga basic example ng hindi homogeneous, sir? Basically, pinakamadaling example is oil and water. Okay? Because however you mix oil and water, di ba? You mix it, oil always collects on top of water. Tama ba? So, basically, that's not a pure substance. Kasi, kahit pag kumuha ka ng sample sa baba, for example, this is the container, and then you mix oil and water, eventually, anong mangyayari? Oil will collect here, and water will collect sa baba, kasi mas denser yung water, then oil will be here. Okay? So, if you collect a sample here, it will be H2O. If you collect a sample here, it will be oil. So, basically, all throughout, pag kumuha ka ng sample, it will have the same composition. So, it's not homogeneous. So, that's why it's not a pure substance. So, now, I hope, okay na, klaro na tayo. Now, we go to water. Siyempre, ito yung pinakauna nating pinag-usapan. So, water is a pure substance. It has states, okay? Liquid states. And we focused first doon sa compressed liquid. Actually, isulat ko ng lahat. First is compressed liquid, then saturated. Sorry sa sa penmanship. I hope this is Clear? Saturated liquid, then we have saturated vapor, and then lastly, we have super heated vapor. Okay, so, itong compressed liquid, okay? This is still water, okay? Water, sometimes it's called subcold liquid. Water that is not on the temperature or that is the saturation temperature of that water at that certain pressure. Okay? So ibig sabihin hindi pa niya na-reach yung saturation temperature niya at that given pressure. For example, okay. Let's have a piston. Okay, piston. Piston. Yung laman ng piston natin ngayon, okay, doon ang piston ko. Then itong laman nito, water. Okay. Sabihin na lang natin ang tubig dito nasa 20 degrees Celsius. Okay? And then the pressure inside is 101.325 kilopascal. Okay. So atmospheric. Atmospheric yung pressure inside. Okay? Now, this is subcold. Sir, bakit? Kasi we know that the saturation temperature of 101.325 is 100 degrees Celsius. Okay? Saturation temperature. Ano bang ibig sabihin ng saturation temperature? This is the temperature upon which water will boil. Okay? Or will start to vaporize. Okay? So now, compressed siya kasi hindi pa siya naabot dito sa 100 degrees Celsius. And it's still 20 degrees Celsius. Okay? Now, we add heat to this. Okay? Add tayo ng heat. Okay? Now, when we add heat to this, na hindi pa siya nasa saturated temperature niya, ang mangyayari, the water here will absorb the heat. Okay? As sensible heat. Sir, ano bang ibig sabihin ng sensible heat? Well, sensible heat is the heat that if we add to the certain substance, it will increase the temperature of the substance. Okay? Kagaya nito, if we add sensible heat, yung 20 degrees Celsius, magiging 100 na ngayon. Okay? And what is the formula for that heat that has been added to the system na yung 20 degrees Celsius na tubig, naging 100 degrees Celsius. Okay? So, the formula for that is very familiar. That is mCp delta T. Tama ba? Okay. Familiar yan. Yan yung formula ng heat. Now, ito yung inad natin na heat. Umabot siya ngayon sa 100 degrees Celsius. Okay? So, syempre, nang nag-add tayo ng heat, syempre, mag-expand ngayon yung tubig. Di ba? Mag-expand yan. Pag mag-expand yan, syempre, lalaki yung specific volume natin dyan. Nito. Oh, sir, bakit? Kasi alam mo naman yung formula ng specific volume. Pardon me, kahit saan lang ako nagsusulat. Ito kasi yung style ko. Anyway, di ba, alam naman natin yung formula ng specific volume, that is that is the volume over the mass. Now, if we expand this because of heating, syempre mag-expand yan. Tataas yung volume without changing the mass. Hindi naman mag-iiba yung amount of matter dyan nang hinit up natin yan. It's the volume lang. Okay? So, tataas yung specific. Pag tumaas yan, syempre, aangat to yung piston. Aangat yan. Okay? Angat niyan, pressure will be constant kasi aangat yung volume, nag-adjust lang. Okay? Until maabot natin itong 100. So, ngayon, naabot na natin yung saturated liquid. Okay? So, it's still liquid. Okay? It's still liquid at 100 degrees Celsius. Okay? I-drawing ko na lang dito. Okay? So, medyo umangat na siya. Piston pa rin. Okay? Water at 100 degrees Celsius. Okay? So, now, we added QS. Okay? Sensible heat. Ito yung inad natin para mag-change yung temperature. Now, naging 100 na siya. Ito na yun yung tinatawag na saturated liquid. Or, liquid that is about to vaporize. Okay? Pang board exam yan, ng mga terminologies. Okay? Explain ko. Ito kasi, ito saturated liquid. Ito yung pag other term nito, minsan lumalabas sa board exam ng mechanical engineering. Ito yung liquid that is about to vaporize. Sir, yung kanina sa compressed liquid, ano yun? Okay. Syempre, ito about to vaporize kasi 100 na eh. Ito, not about. Okay. That is not about to vaporize. Okay. So now, klaro na tayo. Naging 100 degrees Celsius na. Okay. So, ito pala yung goal natin. Yung tubig na 20, i-heat up natin hanggang maging 130 degrees Celsius, ha? Ito yung goal natin. Okay. Hanggang maging 130 degrees Celsius. Sorry, hindi na nakita. Okay. Hanggang maging 130 degrees Celsius. Now, syempre 100 na yan. Mag-a-add na naman tayo ulit. Mag-a-add na naman tayo ulit ng heat para mag 130 nga. Kaso lang nag-add tayo ng heat ngayon. Add ng heat, add. Uy, sir, bakit hindi na to mag-increase? Napako na. Nag-add na, tubig. Oh, liquid state ha? Liquid ba to? Sir, hindi nag-iiba sir. Nag-add ako ng heat pero ba't hindi nag-iiba yung temperature? Pero na-observe ko sir, yung tubig dito, yung iba nagiging gas, nagbe-vaporize. Nagbe-vaporize na. Ito, tubig na. Sa taas, parang may nag-accumulate na gas na. Okay, you're correct. Because actually, when a liquid reaches its saturation temperature at that certain pressure, okay, kaya nga tinawag that is about to vaporize. Any heat that is added more to that will cause it to change phase. Okay? Kaya yung heat na to, tinatawag na natin tong latent heat. Okay? It is the heat that is needed. Okay? That is needed to be absorbed or to be given off to change the phase of matter. In this case, liquid. So, anong mangyayari dito ngayon? Okay? Formula nito is ML. Hindi Mobile Legends, ha? ML. Ang L, may mga apelido yan. Pag ice to liquid, solid to liquid, ano yan? Latent heat of fusion. Okay? Latent heat of fusion. Pag ano naman, from liquid to gas, yung LF mo dyan, LV, o vaporization. Okay? May mga standard tayo na ano dyan. Standard tayo na values, di ba? Minimemorize pa natin yan sa thermodynamics. Pero okay, for now, that is the heat that is needed. O, lagay na tayo ng heat ngayon na heat up. Okay? Puno tayo ng QL, ng latent heat, hanggang lahat maging vapor. Okay? So ngayon, yung piston mo ngayon, okay? Lahat ng liquid, naging vapor na ngayon. It's still water. Okay? Tubig pa rin yan. 100 degrees Celsius pa rin yan. Okay? Ngayon, vapor na. Okay? Itong state na to, saturated vapor na. Okay? So, lahat ng heat na inad natin, inabsorb niya, hindi para i-change yung temperature, kundi i-change yung phase. Kaya naging saturated vapor. Okay? So now, saturated vapor na, yung ibang terminology nito, okay, pang board exam, ang tawag dito, lagay ko na dito ha, that is about to condense. Okay sir. O kanina, saturated liquid, that is about to vaporize kasi malapit na mag-vaporize sa 100. Eto sir, bakit that is about to condense? Kasi naman, vapor to saturated nasa 100. Okay? Sabit lang. Konting heat loss lang dyan. Okay? Magkaroon lang ng heat loss. Yung ibang vapor dyan, magko-condense ka agad. Okay? Kaya na tinatawag dyan na that is about to condense. Okay? Ngayon, inaabot na lahat. Nag-change na ng phase. Nag-add ka pa ng heat. Sir, bakit? Kasi 130 yung ano natin eh. 130 yung kailangan tamaan. So, add ka na naman ng heat. Okay, Q. O ano nang apelido ngayon ng heat mo? Siyempre ngayon lahat na change na ng phase. Yung lahat ng heat na i-add mo naman ngayon is now sensible heat na naman. Bakit sir? Kasi na-change na yung phase eh. Lahat vapor na. So, lahat na ngayon ng heat na i-add mo will be understood by the system to be sensible heat. So, isi-sense niya ngayon, okay, may inad na naman heat si Micah. Okay, so yung 100, magiging 130. Okay? So, after adding heat, okay, itong 100 mo, magiging 130. So, to quantify this heat added, MCP delta T pa rin. So, the mass of the water, CP ng water, delta T, 130 minus 100. Actually, hindi CP ng water. CP ng steam na pala kasi naging vapor na eh. Okay. Madali lang naman to, di ba? Yung iba, hindi alam. CP ng water is 4.187. I-divide mo to ng 2. CP ng ice, di ba? 4.187 divided by 2. Okay? CP ng ice, 2.09. Okay. CP ng steam. Tanggalin mo lang yung sobra. Tanggalin mo tong sobra. 2. Okay. So, CP ng water, 4.187. I-divide mo ng 2, CP ng ice. Tanggalin mo yung sobra, CP ng steam. Yun na yun. Dito, QS, yung CP dito, teka lang CP dito, CP ng water pa. Okay? CP ng water, that's 4.187. At saka yung delta dito, 100 minus 20. Okay? So, now, clear na tayo, ha? Now, eto ngayon, pag yan mag-add ka ng heat, magiging 130, ito na tinatawag na superheated vapor. Okay? Superheated vapor. It means that yung temperature ng vapor is higher to that of its saturation temperature. Okay. So, ano yung, sir, ito, may mga may mga other terms. Ito, sir, madali lang. Okay. Basing here, ano kaya to? Siyempre, that, okay, teka lang Naku, di naman tama. That is not about to condense. Siyempre naman. Okay? That is not about to condense. Kasi, malayo pa 130 na siya Ito lang, nasa bingit kanina That is about to condense. Ito, that is not about to condense. And by the way pala okay, yung difference pala ng superheated temperature na 130 tsaka ng 100 degrees Celsius na saturated temperature, ang tawag dyan is degree superheat. Okay? Yung symbol niyan, ganito, degree superheat. Okay? To get degree superheat, i-minus mo lang yan. 130 minus 100. Meron pang isa, yung degree subcold. Okay? Paano to, sir? Okay? So, yung subcold temperature mo na 20, i-subtract mo lang from 100 na saturated temperature. So, 100 minus 20, that is 80. So, in our case, itong superheated 130 minus 100, 30 degrees. At 30 degrees Celsius, sa degree subcold, that is 80 degrees Celsius. Or 100 minus the subcold temperature na 20 degrees Celsius. Okay. So, para mas maintindihan pa natin, okay, let's draw the TS diagram. Okay? Nang ginawa natin. Okay, sige. So, TS diagram. Teka lang, Ano lang muna tayo ngayon? Bond paper at saka ballpen. Alam mo naman, wala pa tayong budget sa mga high-tech na mga gamit. Anyway, okay. So, ito yung TS diagram natin ngayon. TS. So, let's say that this is 20. This is 100. And this is 130. Okay, kasi temperature to all in degrees Celsius, 0. Okay, ito entropy. Now, sa TS diagram natin, we started off, di ba yung tubig natin, we started off with 20 degrees Celsius. Okay, so nag-start tayo dyan. Now, we added sensible heat. Nag-add tayo ng heat. So, syempre, tumaas yung temperature natin, umabot dyan. Okay, dyan. Nag-add tayo ng heat dyan, sensible heat, umabot dyan. Now, after getting to 100 degrees Celsius, nag-add din na naman tayo ng heat, pero it became latent heat. So, nag-change yung phase. Ngayon, naging vapor. So, yung 100 degrees Celsius na temperature na pako hanggang yung liquid, naging vapor. Okay, and now from that, vapor, nag-add na naman tayo ng sensible heat, so tumaas na naman ang temperature hanggang umabot sa 130 degrees Celsius. Okay, so ito yung tinatawag na constant pressure line. Okay, ito yung 101.325 kilopascal. Sa TS diagram talaga, ito yung linya ng constant pressure. Okay, constant pressure line. So, ito, actually sa TS diagram, ito, this is what you call the F. Okay? And this is G. F represents the saturated liquid and G, the subscript G, represents the saturated vapor. Okay? And actually, okay, maiba kasi sinasabi na, okay, water boils at 100 degrees Celsius. That is wrong. Okay? Kulang yan. Water boils at 100 degrees Celsius provided that the pressure is 101.325 or atmospheric pressure. It is not always true that water boils at 100 degrees Celsius. Pag iba na yung pressure, iba na rin yung boiling temperature niya or the saturation temperature. Yes, iba na yan. Kaya, if you plot all the pressure and temperature, okay, i-plot mo lahat sa TS diagram yung mga constant pressure line, ng lahat ng temperature, it will have a graph like this. Yes, so ito yung graph ng tubig. Okay? At 101.325, ito yung constant pressure line niya. Eh sir, paano pag mas mataas na pressure? So, syempre, pag mataas na pressure, mas mataas yun na temperature. So, yung boiling point niya ngayon, nandito. Maybe at, pag naging 150 yan, 150 kPa, siguro mga nandito yan, mga 110 degrees Celsius, yung boiling point. Okay, so, yung magiging constant pressure line niya, ganito na yan. Okay, ganyan. Okay, iba na. Iba na yung ano niya, boiling temperature. Mag-iiba na rin yung properties niya. Okay? Lahat ng properties ng steam, nakasummarize yan sa steam table. Napakaraming number niyan, di ba? Naalala niyo, yan yung Bible natin sa mechanical engineering. Now, eto dito, okay, this is the critical point. Okay? Eto dito, sa critical point, hinahati niya sa dalawang bahagi. Yung graph natin ng TS. Ito dito, this is what you call the saturated liquid line. Okay? At any pressure, at any given pressure, lahat ng babangga dyan is saturated liquid. Dito naman, this is the saturated vapor line. Lahat ng babangga dyan is saturated vapor. Kaya yung subscript apelido niyan may G. Ito, F. Okay? So, kung gusto natin kunin yung property, say for example, gusto natin kunin yung property ng steam here. Kunwari, sir, ano ba yung enthalpy o kasi yung, alam mo naman, sa properties of steam, we want H, U, specific volume, entropy, to be able to know, there is a purpose why we want this. Kasi ito yung gagamitin natin in the future, in quantifying the work, the heat, okay, if the system is constant pressure, doon na sa properties, not properties, processes of steam. Kasi yun yung nasa cycles, steam cycles. So that's why we need to have this. So what if we need the enthalpy, say for example, the enthalpy of the enthalpy of water at 101.325, saturated liquid. O, syempre, kailangan natin ngayon yung tinatawag na HF. Okay? Saan ito makikita? Syempre, sa steam table, meron niyang naka-assign na column doon. Okay? And then, gusto natin U, internal energy dito. Syempre, UF din. Okay? Now, gusto din natin yung specific volume dyan. O, syempre, BF. And then, entropy, so on and so forth, it follows dito. Sir, pag dito, sa vapor. Good. Pag sa vapor, saturated vapor, syempre, hanapin mo sa steam table yung G. Okay, so Hg, Ug, specific volume G, tsaka entropy G. Okay, lahat yan nasa steam table. Eh sir, paano pag yung gusto ko ito? Enthalpy dyan sa point na to. Ay, madali lang. Kunin mo rin, syempre may pressure ka, di ba? May pressure. Tapos ito, 20 degrees Celsius, may temperature. Punta ka ngayon sa steam table. Table 4. Okay, doon ka sa table 4, yung subcold region. Hanapin mo doon yung pressure, pinakaunang linya, 101.325. Tapos yung may kapares siya na 20 degrees Celsius. Pag makuha mo yon, kung ano yung H doon, yun yung enthalpy dito, internal energy, specific volume, tsaka entropy. Eh dito sir, doon ka sa table 3. Okay, sa superheated table. Pag dito, syempre may pressure ka, tapos may temperature ka dito, 130. So doon makikita mo pag pinagpares mo to, makukuha mo rin yung mga gusto mong HU, specific volume, tsaka entropy. Okay? So we will have examples of that later. To be able to really cement your understanding here. By the way, backtrack muna tayo ha. Kasi we were talking about enthalpy, internal energy, specific volume, entropy. Okay. Ano nga tong let's start with volume. Alam naman natin, 'di ba? Volume, that is the specific volume, that's the volume occupied by per unit mass. Now, ito, entropy. Ano ba 'to? How do you understand entropy? Well, entropy is the measure of disorder, okay, of the particles. The more disordered the particle, meaning kalat. Okay, yung pagkakalat ng molecules or ng substances. Okay? And that is, the higher the disorder of the particles, the higher the entropy. Okay? How about internal energy? Okay? Internal energy, that is the internal force, okay, of anything. For example, this ball pen that I have here. Okay, syempre solid to because its molecules is held together by bonds, okay? Kaya solid to. Now, okay? That energy of the bonds itself. Tapos plus ng kinetic energy ng molecules nito. Kasi hindi mo lang alam, okay? Hindi mo alam, hindi mo makita ngayon sa naked eye mo. But this ball pen is actually vibrating in a molecular level. Oo. So, hindi lang makikita sa naked eye. Pero the molecules of this pen is vibrating. Diba? Oo. And that is comprised. Siguro pag batak na batak ka na, di ba, makikita mo na nagbabibrate. Sabihin mo, uy, Eugene, is vibrating nga. pero, now, we cannot see that it's vibrating. But, it is actually vibrating. And the sum of the kinetic energy of the molecules of this pen plus the energy of the bonds between the molecules comprises what we call the internal energy. Okay? But actually, itong internal energy na to is not the energy totally of the pen. It is the change in internal energy from a certain reference. Kasi actually, you cannot really measure the internal energy. Hindi mo talaga ma-measure what will be the total internal energy of this. But we can measure the change in internal energy because we know that internal energy is a function of the temperature. Anyway, yun yung internal energy. How about enthalpy? Well, enthalpy is the available energy or exergy. Okay, kunwari itong pen na to, di ba, may internal energy ito ngayon. Now, ito ngayon ay in-applyan ko ng work. Ngayon, anong ibig sabihin ng in-applyan? Hinagis ko to ngayon sa mukha mo. Siyempre, paghagis ko sa mukha mo, siyempre, masakit yun. Kasi may enthalpy siya. The internal energy plus the work that I have done on the pen, okay? Kasi yung energy, nagkaroon ng change in energy ng system ng pen, di ba? Initially, wala siyang external kinetic energy. Now, I applied energy from myself, tapos napunta na transfer. It has caused kinetic energy, increased speed for the pen. Now, it has work done on the pen, plus The internal energy, kaya yung formula ng enthalpy natin is U plus PV. So, actually, it's delta U and delta H. So, delta U plus the work done on the system or done by the system plus the delta U, that is the change in internal energy. Okay, so that's how you do it. Now, that's how you get the properties from here, 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 here. Pero ngayon, syempre, alam naman natin yung mga problem sa engineering. Hindi ka naman ng engineering para masarapan ka, di ba? Syempre, papahirapan ka ng mga prof mo, pati ng board exam. Okay, may mga instances, syempre may mga problem na yung mga tanungan ganito, di ba? Okay, a rigid volume, sabihin daw, a rigid volume has a wet mixture in it. Okay, wet mixture, ibig sabihin, may liquid dyan, may vapor. Okay, so, nga pala, dito, di ba, dito, water, 20 degrees Celsius, before tayo pumunta sa problem. Okay, water to. Siyempre, mag-apply tayo ng sensible heat. Di ba, sensible heat. Yung tubig, tataas ngayon sa 100 degrees Celsius. Pero tubig pa rin siya dyan, saturated liquid. Now, we applied another heat. Okay, yun, di-interpret na yun as latent heat. Siyempre, mag-iba ng phase. Di ba, mag-iba ng phase. Pero dito, at this point, anywhere in this line, okay, yung water tsaka gas coexist. Tama ba? Okay? Yes. Kasi, not all of it is gas. Meron pa rin natitirang liquid. And hindi naman lahat ng liquid kasi yung iba naging gas na. Ito yung tinatawag na wet region. Kung saan, water in liquid form and water in gaseous form coexist with each other. Okay? So, dito sa wet region, merong mass ng vapor, okay, here, yung mga naging vapor na, tsaka mass ng liquid. Okay, yung natirang liquid. But, if you add those up, okay, ml plus mv, or the mass of the liquid left, and the mass of the vapor turned already from liquid, if you add this all up, it's the total mass of the water before nag-vaporize. Tama ba? Okay, for example, 10 kilograms dito. 10 kilogram per second before vaporizing. Tapos, after vaporizing, at this point, 50-50 na. Di ba? 5 kilogram per second na yung liquid. Tapos, yung vapor, 5 kilogram per second na rin. Okay? Do you understand? Okay. So, anyway, that is what's happening here. So, some of the liquid will become vapor and some of the liquid will stay as a liquid. Kaya dito, meron tayong tinatawag na moisture, okay? Yung symbol niya is Y, and quality, okay? Yung symbol niya is X. Ibig sabihin ng moisture, ano ba tong moisture, sir? If we talk about moisture, okay, as a jargon here sa pure substances, Thermo 2, it is equal to the mass of the liquid that is left dito sa wet region divided by the total mass of the water going in. So, in this case, mass of the liquid is 5 divided by the total mass 10, so the moisture is 0.5. Okay, so that's 50%. Now, in this case, yung quality naman, that is the mass fraction. Okay, remember mass fraction of the vapor with respect to the total mass vaporizing. So basically, the formula is mv, mass of the vapor, divided by the total mass vaporizing, mass of the water. In our numerical examples, 5 over 10. So it's still 0.5. So 50-50 siya, 50-50 pa pala siya dito. So basically, pag nandito pa, syempre about siguro yung pag nandito pa siya, marami pang tubig, mas malapit pa siya dito sa tubig, it means that 80% is liquid, 20% is vapor. Pag dito malapit na siya maging vapor lahat, syempre dito 80% vapor na. 20% na lang yung liquid. Syempre dito quality is already 100%. Zero na yung moisture. Dito naman, quality is still 0 and the moisture is 100%. Okay. So, yun. Okay na. Now, balik na tayo dito sa pagpapahirap ng prop mo. Di ba? Sabi dito, may rigid container daw. Di ba? Tapos, wet mixture. Okay? So, meron dyan tubig, tsaka meron ding gas o steam. Ngayon, sabi dito, yung volume nito is 5 cubic meter. Okay? Siyempre, papahirapan ka talaga. Tapos, sinabi lang dito, 1/4 daw, 1/4 of the volume here is liquid, and the other, okay, is, gas. So, pag 1/4 liquid, siyempre, 3/4 ng volume na to is gas or steam. Okay. Now, sasabihin ngayon, initially, okay, the pressure inside is 101.325. Okay? Now, yung question sasabihin, heat is added to the system. Okay? Tapos, until the temperature becomes 110 degrees Celsius. Okay? Tapos sasabihin, what must be the quantity of the heat added to the system at constant pressure? Oh. I'm sorry. At constant. Kasi ito rigid container eh. Tama ba? Okay. Kahit hindi sabihin na at constant volume. Pag sinabi kasing rigid container, alam na natin sa thermodynamics, it is constant volume. So, minsan sasabihin lang, what is the heat added? Or the quantity of the heat added to the system to be able to have this system na maging 110 degrees Celsius. Pag mga ganitong questionan na, di ba, medyo mahirapan ka. Kasi, bakit? Alam mo, that the system is 5 cubic meter. Tapos, 101.325, alam mo na yung saturation temperature niya is 100 degrees Celsius. Sir, bakit? Kasi yung pressure, 101.325 eh. So, 100 degrees Celsius yan. Now, the question is, how do you get the heat? O syempre, dadaan ka ngayon sa first law of thermodynamics. Non-flow energy equation. Q is equal to work plus delta U. Okay. Now, because the vessel is rigid, it's constant volume. Ngayon, wala siyang non-flow work. Tama ba? Ito ngayon magiging zero yan. So, Q will now be equal to delta U. So, actually, you need to get, okay, delta U is U2 minus U1. You need to get the final internal energy and the initial internal energy. Okay. So, how do we do that? Okay. From basing in this, okay, alam natin if we add heat, okay, if we add heat, all, kasi magiging 110 eh. So, ibig sabihin, lahat ng liquid dito magbe-vaporize. Kasi ngayon, nasa 100 degrees Celsius siya. Okay? It's vaporizing. And if we add heat to 110, surely it will become superheated. So, all of this will become vapor. And so, to get U2, actually, punta lang tayo sa table 3, kunin natin at 101.325 and 110 degrees Celsius yung corresponding internal energy niya. Table 3 from the steam table. Okay, we can read that. Yung problema yung U1 actually. Okay? Sir, bakit? Kasi, your initial state is a wet mixture. Wala dito, wala dito, wala dito, wala dito. Nandito sa wet region. Wala pa namang table ng wet region sa steam table. Okay? Maybe, it's about here. Okay? Di natin alam. Okay? Now, so anong gagawin natin? Okay. So actually, what you can do first is, because we know that 1/4 of the liquid here, 1/4 of the volume is liquid, 3/4 of the volume is steam, we can get actually the we can get the volume of the liquid, corresponding volume of the liquid. Okay, the volume of the liquid is 1/4 of 5 cubic meter. Okay, and the volume of the gas or the steam is 3/4 of 5 cubic meters. Oh, okay sir, okay sir, okay, good, good. After that, sir, anong gagawin? O, syempre, makukuha mo ng volume ngayon. O, syempre, meron kang density ng water. Tama ba? Okay. Okay. Paano ko yan makikita, sir? O, syempre, makikita mo yan sa steam table. Pero actually, what you can get in the steam table is not the density. It's the specific volume. Tama ba? Okay. Specific volume ng water. Okay, sir. Okay, sir. Good, good, good. Paano ko yan makikita? Okay, dun ka. Kasi yung pressure, 101.325. Punta ka ngayon sa table 2. Doon sa pressure, 101.325. Siyempre, yung katabi niyan, meron na yung BF. So, BF niyan, o ng specific volume ng water, kasi ito, liquid to eh. So, sa F ka, kunin mo for water. Okay, for liquid. Kukunin mo yan. Then, kukunin mo na rin yung specific volume ng gas. BG. Okay, doon pa rin sa 101.325. BG, yung specific volume ng gas. Sir, bakit? Kasi pag makuha mo, yung specific volume ng liquid dito, tsaka specific volume ng gas. Okay? Dito. To get the mass, okay? We can say that the volume of the liquid divided by the specific volume of the liquid is equal to the mass of the liquid. Tama ba? Okay. And also, we can say that the total volume of steam divided by the specific volume of the steam is equal to the mass of the steam. Okay? So, if we have that, anong magiging implication? Anong magiging implication nito? We can get now the X and the Y. Okay? X and the Y. Bakit, sir? Kasi meron ka ng MS and ML. We know that the total mass will now be ML plus MS. Okay? Kasi initially, yung pagpasok niyan before it vaporize is the liquid and the mass of the steam vaporized. Okay? So yun, that is the total mass. So we can get first the quality, which is M of the steam over the total mass, and also we can get the moisture. Why is this important, sir? Kasi this is how you use to get U1. Okay? Because we have the internal energy here sa wet region. Hindi natin alam yung anong property dyan. Kasi yung makukuha lang natin, yung UG, okay, dito, UG, and UF, internal energy dito. You cannot get the internal energy at the wet region. So, to get the first state, U1, okay, we will have the energy balance. Okay? Paano yan, sir? Siyempre, total internal energy of the system, okay? That is the internal energy of the wet region. Let's call that U1. Siyempre, that is kilojoules per kilogram. We multiply to the total mass MT, okay? Equals to the internal energy of the gas inside. So, that's the UG, okay? That's in kilojoules per kilogram, times the mass of the steam or the gas, MS, plus the total internal energy dito ng liquid. So, UF in kilojoules per kilogram times the mass of the liquid. Now, this is true by virtue of first law of thermodynamics. Okay. So, now what will happen is we know that ML plus MS is equal to MT. Okay? So, yung gagawin natin, we can get ML in terms of MT and MS, actually. Oh, okay nga. Oo nga, sir, no? Oh, sige nga. Maano nga? Because here we can say that ML is equal to MT minus MS. So, pag linagay natin dyan sa ML, sinubstitute natin to dito, we will have MT times U1 equals MS UG plus ML, which is MT minus MS times UF. Now, if we try to distribute that, it will become MS UG plus MT UF minus MS UF. Okay. Now, what will I try to do is I will collect terms with MS. Okay? Terms with MS. Siyempre. So, ano mangyayari dito ngayon? Siyempre ito, UG, tsaka UF. So, ito magiging ano to? Okay? It will become, so, ngayon, I will correct this. To empty to, empty. Kasi UF times empty. So, I will collect this. It will have MS times the quantity UG, okay, minus UF, okay, plus MT times UF, and to the right left hand side, MT times U1. Dividing both sides by MT, okay, MT, we will have now U1 equals to, ito magiging ano to, MS over MT, okay, times UG minus UF plus MT over MT UF. Ano to, class? MS over MT. That is X. That is quality. So I can substitute this with X UG minus UF plus ito. MT over MT, that is 1. So that's basically just UF. So rearranging, I will have U1 equals to UF plus X UG minus UF. So is this familiar? Yes, this is familiar. Because this is the formula to get the property, okay, the internal energy at the wet region. So this is how you do to get U1, and then after getting U1, U2, nakuha mo na, U2 minus U1, you get the heat needed to be able to raise the temperature of this liquid inside to 110 degrees Celsius. So basically, by virtue of this, it follows for all, okay, for all the properties, okay, for all the properties of water at the wet region, here, okay, using this formula, it will become, for enthalpy, it will become H is equal to HF plus X Hg minus Hf. Or specifically in the steam table, we have a column for that, and this is called HFG. Okay, so we can have H is equal to HF plus X HFG, and U is equal to UF plus X UFG, and S is equal to SF plus X SFG, and then V is equal to VF plus X VFG. So this is how you get the property of the steam, okay, the enthalpy, the internal energy, the entropy, the specific volume at the wet region. Okay? So basically, dito lang muna tayo. We will have a problem solving later on a separate video. And I hope I've been informative. Okay? So basically, this sums up the properties of steam. And I hope hindi kayo maboard sa mga bahay nyo. Okay? Stay safe, stay home, and enjoy the videos. I will have a series of videos more on mechanical engineering series. Thank you and God bless.
And by the way pala, may pinapasabi si Tagoro. Anong MLML? Mag-aral ka ng termo.